JavaScript can only do one thing at a time. One. Yet it juggles your clicks, your timers, your network calls all at once without dropping any. That is not a contradiction. That is the event loop. And in 6 minutes, it will be obvious. Picture a kitchen with exactly one chef. That chef is your JavaScript thread. One pair of hands, one dish at a time. Here is the trick. When a dish needs 20 minutes in the oven, the chef does not stand there watching it. The oven has a bell. When it rings, a ticket goes on the order rail. The chef finishes what is in hand, then takes the next ticket. Nobody blocks, everything cooks. Before we go deeper, let us pin the vocabulary, because every other tutorial and every interviewer will use the formal words. The chef is your single thread. The ovens are web APIs. The order rail is the task queue. You will also hear callback queue or macro task queue. Same thing, 3 names. And a ticket is simply a callback. Keep both languages. We will speak them together. Before anything asynchronous, watch the chef's hands. Every function call stacks a plate. A call inside a call, plate on plate. Finish the top plate, lift it off, resume the one underneath. Last in, first out. This tower is the call stack, and it is the only place JavaScript ever runs. The real machinery has 4 parts. Your code runs on the call stack, the chef's hands. Timers, fetches, file reads, they run in web APIs, outside the thread entirely. Those are the ovens. The browser owns them. When one finishes, its callback joins the task queue and waits. And the event loop is one humble rule forever. Is the stack empty? Take one ticket. Repeat. Notice what that rule quietly promises. The chef always finishes the whole plate first. The formal name is run to completion. No function is ever interrupted halfway. Remember that word. It is doing a lot of work. And here is a detail that quietly answers everything. Your clicks are tickets too. You never call your click handler. The browser catches the click in web API land, wraps your handler in a ticket and queues it. Every event on the page enters through the same reel. Now the classic. 3 logs and a timeout of 0 milliseconds. 0. Surely that runs immediately? It cannot. 0 or not, SetTimeout always takes the detour. Oven, queue, and only then the stack. The number is a minimum wait, never a schedule. Run it, 1, 3, and then 2. The callback could not even be considered until the stack was empty. 0 means not before 0. It never means now. Now a real dish, a fetch. 3 full seconds of network. If the chef waited, your page would be dead for 3 seconds. Instead, the network oven takes it. Meanwhile, the stack sits empty. Clicks handled, animation smooth. When the response finally lands, its callback takes a ticket like everybody else. No threads, no waiting, just the reel. Which sets up the most common misconception in modern JavaScript. This function awaits a fetch. Question, does await block the thread? No. Await pauses the function, not the chef. The rest of your program keeps running. The paused function resumes later through a queue. Await is just the oven and ticket dance wearing nicer syntax. One more tenant shares this kitchen, the renderer. The browser wants to repaint every 16 milliseconds, 60 frames a second. And paints only happen between tasks. A healthy handler, 3 milliseconds, invisible. One lazy loop, 5,300 missed frames. That is what jank actually is. And here is the dark side. One long loop on the stack and the chef never gets back to the rail. No clicks, no timers, no rendering. The whole page is frozen. Not because JavaScript is slow, but because you never gave the loop a turn. So how do professionals do heavy work without freezing anything? They slice it, do one chunk, then schedule the rest with a timeout of 0. Yes, the detour is the whole point now. Between chunks, the loop breathes, clicks process, frames paint, and the work still finishes. Same total effort, 0 frozen pixels. This one pattern is the heart of every responsive UI. Time to prove you own this. 5 lines. Pause the video, seriously, and predict the output. A, D, then C before B. The 0 timer was ready first. And notice, both timers fired late because the blocking work held the stack. If you call that, you have the model. One last confession from SetTimeout. Even unblocked, 0 is not 0. Browsers clamp nested timers to about 4 milliseconds and background tabs to a full second. So read the contract one final time. Run me no sooner than this. Delays are minimums. Everything else is the real.
One last door to open, Node. No browser, no DOM, no clicks, and yet the exact same chef, the same rail, the same humble rule. Only the ovens changed. Files, sockets, timers run by a C library called libuv. Learn the loop once and you own it everywhere JavaScript runs.
Let us retire the myths. JavaScript is not secretly multi-threaded. SetTimeout 0 is not immediate, and async does not mean parallel. The truth is smaller and better. One stack, patient queues, and waiting that happens outside the thread. Concurrency without threads. The one rule to code by: never block the chef. One chef, ovens with bells, a reel of tickets, and a loop that asks, stack empty, next. That is all of asynchronous JavaScript. Except promises cut in line. Next Tuesday, micro tasks. The VIP queue SetTimeout never told you about. Subscribe so it finds you.